There are many benefits to increasing AI and autonomous systems capabilities in defence, including removing humans from high-threat environments, reducing sustainment costs, achieving greater mass on the battlefield, exploiting asymmetric advantage, accelerating capability development timelines, and capitalising on advances made in the civil sector. An effective and practical methodology to reduce ethical risks will best support defence and industry in developing AI systems. Developers already must produce risk documentation for technical issues. Similar documentation for ethical risks ensures developers identify, acknowledge, and attempt to mitigate ethical risks early in the design process and throughout test and evaluation. This video introduces 4 tools. The first is Data Ethics Canvas by the Open Data Institute. The remaining 3 tools have been developed specifically to assist defence and industry in developing AI systems for defence. 1. An AI checklist for the development of ethical AI systems. 2. An ethical AI risk matrix to describe identified risks and proposed treatment. 3. A legal and ethical assurance program plan, LEAP, to be included in project documentation.
The Data Ethics Canvas by the Open Data Institute. This is an open access canvas, and it enables you to really interrogate why you're collecting the data you're collecting, what problem are you trying to solve with this data, what sort of security protocols and privacy constraints need to be put on the access to that data and the way it might be utilised, who might be harmed by the collection or use of this data in an AI project, and what might you be doing to mitigate the risks of the use of that data. Because at the end of the day, AI is powered by data. So if you don't have a good grip on what data you're using and why, and making sure that it's secure end to end, then you're not being ethical with your AI project.
So the Data Ethics Canvas for us was an initial framework to allow our engineering teams as well as our non-engineering teams, so the military personnel who are advising the project, to consider a variety of ethical aspects of our data, how we curate the data, preventing biases in our data, ensuring that we can trace our data back to its original source for our machine learning models. And that gave us an initial framework and almost just a brainstorming session of things that we need to consider for our specific project from an ethics standpoint. So the Data Ethics Canvas helps us consider the end user and who might be associated with the results of the AI, but actually really asking us those sorts of questions of what happens if something goes wrong, what if there's unjust bias, and how do we mitigate against those things? And then our engineers can go away from that and work out, okay, how do we produce an unbiased network? What happens if our AI labels something in a way that it shouldn't label? How do we change our confidence levels to be more sure about one thing, but we don't have to be as sure about another thing, so we flag things from an ethical standpoint if we're really unsure about something, and provide that information to the user to prevent their cognitive bias, that they make a better decision.
The components of the AI ethics checklist are: A. Describe the military context in which the AI will be employed. For example, is your system used for force application, force protection, situational understanding, sustainment, enterprise functions, and so on? B. Explain the types of decisions supported by the AI. Are these one of decisions by a single decision maker, sequential decisions, cooperative decisions, or decisions under conflict? C. Explain how the AI integrates with human operators to ensure effectiveness and ethical decision-making in the anticipated context of use, and countermeasures to protect against potential misuse. Create scenarios and show how systems operate in these scenarios. Test using gaming and simulation and experimentation. Demonstrate in trials and exercises. D. Explain frameworks to be used, for example, regulation, ISO standards, code of practices, or AI ethics tools such as the Data Ethics Canvas, LEAP, and AI ethics principles. E. Employ subject matter experts to guide AI development. For example, data and AI specialists, end users, decision scientists, military ethicists, legal experts, systems engineers, and so on. F. Employ appropriate verification and validation techniques to reduce risk, including providing a requirements analysis and verifying these, providing a logical analysis and validating it.
The AI ethics checklist is a set of checks and balances to make sure that your AI project is considering ethical risk in an appropriate way. The main idea is pretty simple. You need to imagine how your technology might be deployed in its anticipated context of use. So some AI technologies are going to be really useful, for example, in an HR setting, and will never be used out on the battlefield, and vice versa. So what's the context in defence that your AI system is going to be deployed for? Now, come up with scenarios under that deployment which involve ethical risk. Now, you may not know in your project team what those ethical risks might be, so you need to bring in those who do. So that's the third part, is make sure the subject matter experts that you have inside your team or outside of your team are brought into workshops in order to identify ethical risks in the first instance, and then to sort of workshop mitigation strategies for those risks that you can put into your risk matrix. So who are the people you need? Well, you probably need people who are good at decision science, so actually understanding the kinds of decisions that are going to be made by the artificial intelligence and the humans involved with the technology. You probably need to bring in military philosophers and other kinds of philosophers, or ethicists who have backgrounds in ethical theories and ethical reasoning and decision making. You want end users in the military, so who are the defence personnel who are going to be asked to use this equipment? How do they understand its intended use in the intended context? Because they have the deep expertise in the actual decisions that need to be made on the ground. So you want end users, and you want those in senior positions who might be the ones authorising the use of those technologies as well. You want people who have human factors background experience, those who are really well versed in how to bring humans and machines together, and the sort of information interfaces that will enable and optimise human decision making, and those mixed teams to flourish under deployment. That's just some of the expertises that you might need to bring to bear. You're going to need people with legal backgrounds to manage the legal considerations. You're going to need data privacy and security experts if you're dealing with particular issues around those matters. So each part of these systems will need experts who are able to provide best practice, apply legal frameworks, apply regulatory requirements, safety requirements, and other types of considerations to ensure that these systems are trusted when they're fully developed. Finally, once you've got those scenarios and you know what the risks are, you're going to need to build the systems in order to mitigate the risks, and then test those systems. So you're going to need to test and evaluate the AI systems with human operators to make sure that they work as intended, and that you can verify and validate the algorithms and the decisions that they're being made before you're hoping to get those technologies to be acquired by defence. When we think of the sort of decisions that robotics, autonomous systems and artificial intelligence can help us with, it's important to realise that decision making and decisions themselves can have different structures depending on what an agent, a human or a robot or an artificial intelligence are thinking about and what their obligations are. So, for example, I'll give you 4 different kinds of decisions that might change the ethics of how you might deploy these systems. The simplest case is when you have a one-off decision by a single decision maker. So that might be your decision to go to sleep at 9 p.m. or go to sleep at 9:30 p.m. That's just one decision, and the consequences of that decision you'll feel the next morning if you needed a little extra sleep. When we might think of a robotic situation, a drone might be flying autonomously, for example, and it might have a set of parameters where, suppose communications go down, and that drone has a decision point, and it says, when my comms go down, I need to go home. So that drone might have a one-off decision to go home, back to base, based on its programming. Contrast that with a sequential decision-making algorithm. If you've got an autonomous flying drone and it is manoeuvring around and navigating, it might be making hundreds of decisions about how it's actually navigating through the air and responding to the environment that it's flying in, that one decision depends on the previous decisions that it was making. Those sequential decisions are going to be very influenced by the previous decisions that that system has made, and often don't have intervention on them. So sequential decisions have consequences based on previous decisions and ongoing dynamic changes. One-off decisions are things that happen and then there is an action that occurs. Another sort of decision is what happens in collective decision-making contexts. So if you've got a number of assets, for example, in a search and rescue operation, and you have different kinds of human groups and different sort of robotics and autonomous systems assets, they need to work collectively and cohesively together in order to make decisions about how they need to save a person or persons from a harm situation. That's really different to a single decision maker and will have different ethical risks associated with it. And the final example is decisions under conflict and when you have different interests at stake. And the way you might have to make a decision when you're facing an adversary who might be seeking to harm you or those that you're caring about, again, provides a different set of considerations, and those considerations are relevant regardless of whether you have humans or robotics, autonomous systems and artificial intelligence as part of making those decisions.
For example, you could use in force application or force protection, you could use an autonomous vehicle either for attack or defence, or even to carry ordnance or carry cargo or personnel. So that's within the autonomous systems. You could use artificial intelligence in command and control. So one of the applications we're looking at is how you commanders make better decisions by taking recommendations of artificial intelligence systems that can gather enormous amounts of data and bring out really important things for the commander. You could also use artificial intelligence for force protection, such as for medical purposes. One of the real effective uses of artificial intelligence is to helping doctors identify and diagnose issues by taking a large amount of information from their patients, such as scans on identifying things like lung problems or cancers or tumours and similar things like that. In the area of situational understanding, artificial intelligence is also being used and can be used to take in a whole lot of digital imagery and identify things of interest and classify things within that imagery. In the areas of force generation sustainment, you actually have the greatest number of artificial intelligence applications, including in logistics, in optimization, in prediction, and because force generation sustainment, even though it's the least combat of these functions, it is closest to the commercial and the civil area, and there's a great deal of artificial intelligence applications in that area as well. So when we choose to use these applications in the military context, and in conflict or in the grey zone or close to conflict, we do run into a lot of ethical issues. And there's a lot of things that we have to consider that they even considered back in World War II with the new weapons as the technology was brought in each of those applications. And I'll give you some examples from those contexts that I mentioned before. For example, in the command and control situation, the artificial intelligence which is supporting the commander in his decision support mustn't be biased. It must know what information the commander wants and doesn't want. But most importantly, the artificial intelligence should have value alignment. So it should have the same values as the commander or the government or the force which it's working for. So that's a key thing of importance. Another example of an ethical situation will come from the medical example I gave you earlier for force protection. So we would envisage in the very near future the ability to monitor lots of medical parameters from our combatants and our non-combatants to make sure that they stay safe, to see if they're wounded, and to ensure that they operate at their maximum capacity. This brings up a whole lot of issues. For example, where does privacy come into it? How many things can you monitor of a person in the services or outside the services without causing an ethical issue with the privacy? And one of the other issues which came from a workshop that we ran in 2019 is even more complicated. What happens if you have a female combatant who is monitored medically to make sure that she's okay, about to go into a combat zone, and the monitor, the AI, detects that she is pregnant? Do you inform the combatant? She may or not know she's pregnant. What do you do with that data? Should you throw that data away? What do you do with the combat? So it's a huge area that you can come up with, and even with that non-combatant use, it's not indirect combatant like the use of a flying bomb, there's a lot of critical areas where you have to consider the application of ethics with the use of robotic and autonomous systems in military and in conflict zones.
Robots can certainly also be in a position to fight other robots. I don't think there are any ethics in that aspect, in the sense of unmanned systems. And we'll need to be successful in that, so that if there is a fight that requires our robotic systems to take out a first wave, then we have to make sure there aren't leakers. So although there may be a robot-on-robot battle, that'll be important to minimise the effect on people afterwards. In terms of what risks we might perceive for humans involved in ethical decision-making in this kind of future, in one way we might want to see the human in a sense as hero. But there's an issue, because those people that are the hero can also be the hazard. And the machine can play a role in helping to ameliorate the hazard. So if you like, to maximise the chance of heroic acts or and so on, and ethical acts, and to minimise those that are not. Civilian deaths are an example of that. In the Middle East area of operations, reports that are public have expressed that in terms of civilian deaths, around a half of those civilian deaths were collateral damage, but the other half were simply not lawful targets. So there's a role here for the machine and the system, not only to monitor, but also to help intervene, to give pause for commanders, to instill tactical patience, to do some of the things I described earlier in terms of being able to identify symbols of protection on buildings, on people, on things. These are all part of what can be done. It could be that there are times in that human as hero hazard balance that the machine takes the initiative rather than the human, or vice versa. And that balance and that mix needs to probably be determined empirically. Furthermore, decision making simply by people or only by machines at each end of the spectrum might be a vulnerability in a range of ways. So I would see in the future we'd want to see decision making more fully integrated between humans and machines in order for the strengths of one to offset the weaknesses of the other, be that a human strength and a machine weakness or vice versa, as the case may be. There's also a question about humans and their role in this. So I would view that potentially human has this role of command, and that is the expression of intent to another. It includes authority, responsibility, competency, and a role for humans and machines in control to realise that intent, to express a capability for action, and shared awareness in order to bind those together to act. However, the notion of that command and control being hierarchical in future may not be the most efficient way for the ADF to operate. The segregation of assets done through hierarchical command and control could be made more efficient potentially in the future as we build greater trust in these systems to share and more dynamically bind components of control together to effect a greater sense of manoeuvre warfare in the way they operate.
So the scenarios that we considered, we wanted to trigger scenarios where humans would trust the AI and it improved or reduced the cognitive workload of the human in essentially high tempo scenarios where there might have been a number of objects moving in and out of collateral damage zones, as well as things that the human might not be able to pick up. So for instance, uniforms and small objects on a smartphone was another example where we can pick that up on AI because we get the full resolution of the video. And then similarly, we wanted to look at scenarios where the human shouldn't trust the AI, or the human has to overrule the AI because of various reasons. For instance, they might be using a protected symbol to try and avoid being targeted, and the human's got to justify a decision to override the AI, or where the AI is simply unsure about the decision and the human needs to make an ultimate decision on that matter. So the scenarios designed have been set up and have helped inform us in how we actually integrate the rules of engagement, laws of armed conflict, and ultimately the human factors aspect of integrating with the AI with the human. So whether those are warning messages or whether we actually put the AI in the loop or the AI on the loop, the scenarios help inform that, because in some instances we simply want a warning and we want to carry out with the human because we might not want the biases. In other instances where you may be breaching rules of engagement, we may have a requirement to actually justify, through self-defense or loss of protection or any number of these reasons. The scenarios helped inform that from a design perspective. So some of the technology features we've added to reduce ethical risk is really at the training of the AI level, for instance. So we trace every single neural network back to every single piece of data that was used that went into it, as well as every data it was validated on. And then we push that through out as a model, and we've got videos and plots, and then we do performance based on the accuracy of the resulting network against the validation data set. And all of that for us is about establishing a level of trust in the AI. And you'll never have perfect 100% accuracy. Anyone who says you can do that is lying. So it's about the user and the person who makes a decision on whether to deploy this actually understanding what level of trust they should have in it, and therefore the fact that they do need to cross-check what's being provided to them. So the legal and ethical workshops were done almost from project inception. So we initially engaged with a former military legal officer from the Australian Defence Force who deployed on operations. He gave us a number of scenarios where there were certainly difficult decisions that had to be made based on limited intelligence, as well as things that we had to consider from the standpoint of the 6 steps of targeting. And that helped establish the initial framework from our user interface perspective. From there, we invited a variety of moral philosophers, ethicists, lawyers, human factors experts, and we put everyone together and we considered what does AI supporting laws of armed conflict and rules of engagement look like, and how do we implement that from a coding standpoint. What came out of that was about a 70-page legal and ethical framework based on a variety of ethical principles, as well as the ADF's 6 steps of targeting and the laws of armed conflict being the Hague Convention and the Geneva Convention, and how we would create that framework and put it into our, ultimately, Athena artificial intelligence.
Create an ethical AI risk matrix with detail for each project activity. Define the activity you are undertaking. Indicate the ethical facet and topic the activity is intended to address. Estimate the risk to the project objectives if issue is not addressed. Define specific actions you will undertake to support the activity. Provide a timeline for the activity. Define action and activity outcomes. Identify the responsible parties. Provide the status of the activity.
The Ethical AI Risk Matrix, and this is a project management tool that you can use in order to identify ethical risks in your AI project, assign those ethical risks to an individual who needs to take responsibility for mitigating those risks with a limited amount of time. But it has to have a schedule and it has to have some obligation to resolve them. But it enables a project to keep track of these ethical risks and to have accountability for how they're managed when that technology does go into service or operations.
So in regards to how we manage risk throughout the project, we use an ethical AI risk matrix. And what that does is that allows us to look at what are the ethical risks for the project, what are the actions we need to do to mitigate those risks, who's responsible for it, and at what time are we going to do it. And at every milestone of the project, as well as periodically, we actually review these ethical risks, and they've either been mitigated, they've been closed out through the design, or they're ongoing and we have to continue to monitor them. And that's really the way that we manage those ethical risks for the product as it goes through higher technology readiness levels.
The LEAP is the abbreviation we've given to the Legal and Ethical Assurance Program Plan, which is quite a big mouthful, but it's something that we thought was important, particularly for those projects which are very complex, have a lot of AI in them, heavily enabled by AI, and possibly have some serious consequences as a result of the AI. So it's the highest level, most complex and most resource intensive tool that we have. And so you really only want to use it on major projects with artificial intelligence components. And what the LEAP is, it's part of a whole suite of tools which are plans which are used by the government, used by the Commonwealth, to make sure that the provider of whatever service or software you're acquiring is going to meet our requirements in many ways. So there's a software safety plan, there's many safety management plans, human factors plans. In this case, we want to make sure that the Commonwealth gets what it wants in what the contractor is going to deliver, regarding the legal and ethical aspects of artificial intelligence it has purchased. It comes in a form of a plan which you give to the contractor in the early phases of contract negotiation. There is normally a basic plan which you modify depending on the project that you have and the requirements of the government, but also the capability of the contractor. The contractor and the government will negotiate the outcome of the plan, which is a framework which will tell the government, which will tell the Commonwealth what the contractor is going to do regarding legal and ethical assurance within the program it's buying. And that could be buying a platform, it could be buying a software system, it could be buying a whole service of which only a part is artificial intelligence. So there's quite a range of things that it has.
The Legal Ethical Assurance Program Plan. Now, that document is an iterative discussion between the developers and Defence to enable some of those legal and ethical issues to be contemplated and incorporated during the design and development phase. So we know at the introduction into service of capabilities, we know at different gates along the way, there are certain legal compliance documents that need to be provided to support the application or to support the acquisition of those particular capabilities. The purpose of the LEAP is really to have those considerations built in to the design and development process. So once the capability gets to that introduction into service point, those AI systems don't have to be unwound to have those considerations incorporated into them earlier on. So, for example, the requirement for distinction is a general international humanitarian law requirement that means that there is a legal obligation for the ADF when they're using force to distinguish between combatants and civilians. So how does the Defence Force know when they're buying a RASAI capability that is purporting to be able to do that, to identify and then prosecute targets, that it will be doing so to accord with that basic principle of international humanitarian law? So there'll be questions asked about things like, what's the pixelation of the particular feed that the system is relying on? Is there a presumption that anybody who can't be clearly identified would be deemed to be a civilian, which also accords with some of our legal obligations? What indicia are being used to identify combatants, and is that specific to a particular conflict, and can that be adjusted to a particular enemy set depending on where the system is anticipated to be used, or is it more general than that? And in those considerations, that will assist also in identifying how that system can be used when it is introduced into service. Because if some of those answers at that earlier stage demonstrate it doesn't have the fidelity to properly identify a combatant from a non-combatant, then the use case for that system is not going to be in a targeting context. It may only be for ISR to support other decision-making and intelligence tools.
The main aim of the LEAP is the contractor will provide to us, to the government, an explanation of what it's going to do. Once you agree on the plan, a plan is delivered to us, you check it as the project goes on to make sure that the contractor is doing exactly what they promised they'd do and what you'd agreed upon. How does this plan interact with the other plans, the test and evaluation? How are you going to verify that it will occur? What sort of people are you going to involve? What sort of frameworks are you going to set up to check that the contractor, that the service provided will meet our requirement?
I think Defence should expect a good LEAP will provide an opportunity to iteratively develop a capability so that when it is introduced into service, it meets the legal and ethical needs of Defence when that capability is being used. It should reduce the time lag required to conduct that certification process, but also it should then enable Defence to have a better understanding of how that capability can be legally and ethically incorporated into its actual operational design, so that systems aren't being promised as a panacea to a particular problem when they actually can't deliver on what was being anticipated at the start point of delivery, but also so that there can be a concurrent building of trust in the assurance of that system, trust in how those decisions are being made. So when those systems are actually introduced into service, there's rigorous testing that can be demonstrated to show those people who are relying on these systems for their protection and for decision making in respect of the use of force, that they'll be meeting their legal obligations when using those particular systems.
So the LEAP will help Defence by giving Defence a clear understanding of the contractor's expectations of how much work and effort will go into the legal and ethical assurance, but also to ensure that the Defence meets its own requirements, both from the legal framework, from the stakeholder framework, to make sure the whatever is being acquired is fit for purpose, but also the requirements placed upon us by our own governance, but also our social responsibility. So the LEAP can be used for any sort of program, not just a platform, a software. It could be software for human resources, for medical reasons, or for logistics, and any of those we would like to have an understanding of what effort is going into ensuring that the legal and ethical components of the program and the artificial intelligence within the program have been dealt with. One of the most important parts for an AI developer is understand what framework Defence is trying to follow up, and to understand what our requirements are and the aspects which are really focusing on. Each project will have a different LEAP because you're building a different service or technology, but also be used in different environments. So this will change the legal and ethical issues associated with the service, which means that the contractor has to understand what Defence is looking for in the different areas and in the different contexts that we use the LEAP for. The other part the contractor is to use the LEAP for is to articulate to Defence what they're thinking. So is it a large program? Is it a small program? Does it cover many other aspects, or are other aspects captured in other areas in the project, in safety or software management or human factors?
Defence personnel should think about who to talk to when they're developing a LEAP with industry, universities and within Defence capability about what their particular area of expertise is going to be to assist in understanding the legal and ethical issues associated with that particular capability. That doesn't necessarily just mean lawyers. I mean, I should say it just means lawyers because that's, lawyers write themselves into everything. We wrote ourselves into the Geneva Conventions, so we were definitely there. But in respect of engaging those people who are doing the design, engaging the experts who can articulate clearly how is the algorithm being developed? What does that algorithm then mean when it's having certain data inputs put into it? Is there bias in that data that needs to be addressed or considered? The process itself needs to be iterative, and it really does need to be a discussion between the capability project industry and Defence, with the use of SME like lawyers, ethicists, and those designers and researchers and experts in AI that can translate effectively the geek to grunt is probably a great way to describe it, with those lawyers and ethicists shoved in on the side to make sure that information actually aligns with Defence's needs, but that the industry and the project are obviously going to have business efficacy and are not going to waste their time and money in developing a system that's not ultimately going to be picked up by Defence.
Defence personnel have to understand what their requirements are. So they have to fully understand the system which they're procuring and the issues associated with that. So from the LEAP, they should be able to understand where the issues might be, how they're being addressed by the contractor, and then how it's going to be verified. So all part of the plan is to make sure that yes, the work has been done, but we must be able to verify the activities within the LEAP, which we find important, particularly in the test and evaluation and the verification.
We don't want it to get a product to an acquisition standpoint and then we go through a weapons review where our AI combines with a weapons system to form a means of warfare, and we find that our product was not defined effectively from day one to be used in an operational scenario, because that would be a waste of effort and we wouldn't end up producing the capability that we set out to do. So by considering it from day one, we can actually set up a framework that will meet the requirements of a weapons review upon the time of acquisition, and we can ensure that the hard work we're doing now will result in a capability when it comes time to deploy this in theatre. When it comes to RASAI in Defence and ethics associated with them, I think it's very important to consider how has a given company or a given AI supplier establishing trust in that RASAI product, and understanding that, upskilling yourself in how do we establish trust in these products? How do we provide assurance? What sort of testing was done to those products to establish that level of assurance? And ultimately, that should be the most important thing before you start giving this to your soldiers, seamen, or aircrew.
I'd also recommend you talk about ethics with your colleagues. Talk about it with the general public. The general public always has a view on this, and they're really worth listening to because that's who we in defence and outside of defence are there to represent. Have an opinion, build your opinion, and build your character in the process.
I'd say to people, educate yourself. I mean, we are wonderful at training and educating people in military institutions, but you cannot spend your life in the schoolhouse. The vast majority of your time in the Australian military is going to be spent in a unit and on operations or on task somewhere outside of the schoolhouse. You need to dedicate yourself to learning about these systems. Do some professional reading, maybe do online learning courses, but you need to understand these technologies and how they impact on individuals and on organisations. Technological literacy by our soldiers, sailors and aviators and by our most strategic leaders is a key capability for our organisation moving forward, and will underpin not just how we do things on the battlefield or in a humanitarian assistance operation, but will underpin strategy making and policy making by our strategic leaders.